Hello and welcome to the next session with our nice exterior environment. So I was thinking a bit, and before we continue to further dig into all the cool stuff that we can do here, I just wanted to show a few things and explain some of the settings and things we can do inside of Unreal a bit more. So in case that anyone would like to do a certain workflow or so, they can and they understand how these things work. So one really important thing to note is that this scene was not built for Unreal 5. So it was actually built for Unreal 4, and Unreal 4 had obviously a bunch of features are not there compared to Unreal 5. And some features are also rather expensive, like, for example, doing tessellation on the terrain is really expensive and can be quite taxing. It can also introduce visual artifacts when you tessellate the terrain quite a bit up close, and then over distance it sort of tries to load back into the normal terrain grid structure, so to speak, and it can have little breaks and stuff like that. And one really interesting thing is my buddy Andrew again. He came up with a really cool technique. So there is a feature inside Unreal that is called pixel depth offset. And what he basically did was he used the pixel depth offset together with a height map, and he displaces the pixels based on the height map in screen space, and then he uses the screen space contact shadow feature that Unreal has to cast sort of virtual shadows from the geometry. So you can see here that the bark has all these small tiny little shadows that make it seem like the object has a lot higher geometry than it actually does. We can see it here, for example, here on the bark. We can see all these things are here, all the leaves and all that kind of stuff. It casts these shadows, which makes it seem like there's three-dimensional geometry when there actually isn't. Here, this is a very beautiful example as well with this little wooden pole. And that is a technique that is not super well known. I think, I wouldn't say that he was the first one to do it, but maybe he actually was. So, a lot of people have been studying this content and they were like, oh, wow, this is actually really cool, and it adds a lot of detail to the surfaces. So he was doing this on the terrain as well, and with that he got shadows from all the little details. And one of the things that we have is when we don't actually have geometry, things can feel rather flat because they are normal mapped, so they are shaded correctly in terms of just where the light hits and where it doesn't. But it doesn't mean that the normal map features actually cast shadows onto other areas of the texture, which obviously makes things look flat. So this scene here was built with the same techniques. So almost everything in here uses pixel depth offset and has the height maps hooked up and uses the contact shadows in Unreal here to mimic that sort of depth behavior. So why is that important? Well, one of the most important things is that Nanite is not supported right now, because this is 5.03. This is not 5.1 or something, because that's not out. It's not a custom build from GitHub. So these features, they have been improved, but this is the normal version. So right now there is no support for masked materials. Foliage is a little bit broken. There is no support for pixel depth offset or vertex animation or vertex world position offset in that sense with Nanite. And that means that if I go into the Nanite visualization here, you can see that like some of the mesh scattering that is here is using Nanite. There is like a few parts of the cliffs, because like a lot of the cliffs are actually splines, and splines also don't support Nanite, like spline meshes right now. So you can see here that the exterior, for example, for the diner also hasn't set Nanite to work, because there is a part of the mesh that is the glass, which uses a translucent material, so again, not supported. But if we go inside, we can see that Nanite is turned on for a bunch of these meshes. However, looking back at the outside here, what this also means is that our geometry here is not as detailed as you would potentially like to have it with the Nanite meshes and all that kind of stuff. So to basically still get like a lot of detail, this screen space shadowing technique with the height maps was utilized. And right now, I'm using the virtual shadow map, and I actually found out something really interesting. So what I'm going to do is I'm going to switch this back to the normal shadow map here. And now if we just like go down here, we can see that all of this looks basically exactly as we expect this to look, right? So there's not really any shadows from anything. Like we do get like some nice screen space GI bounces here on this little, so this is like all the mesh scatter, right? All these little stones being scattered around here, and some twigs and stuff. And we can see like the twig is actually getting a little bit of the shadow map. But then again, like the shadow map is using cascaded shadows here. And it's just not enough resolution detail to pick up on the small stuff. And then again, we also have nothing that really makes the texture itself. So let's go here, because here is like no mesh scatter, as you can see. There's the mesh scatter. This is just a flat texture, right? And this is kind of interesting that we have a lot of this stuff here under the terrain. Very interesting. Not sure how that happened, but we'll just accept this. So when we look at this here, like again, this is very flat. So what was done here was to basically say like, okay, we use this pixel depth offset to cast shadows. And again, if you want to understand how this works, because we can't share this content since it was sponsored, but if you want to understand how any of this works, you can get the free Rural Australia content, and you'll see how the shaders are being set up, how it's all done. It's pretty straightforward, so it's not like voodoo or anything. So now inside my directional light, I can search for contact, or just like this. And we can see here is this thing which says contact shadow length. And so this is not like, it doesn't have a flip or anything. So what we need to do is we just need to say how long they're supposed to be, and then they happen. So for one thing, like this feature was not necessarily designed for this in particular, but what this was designed for is kind of like, let's have a quick look here. So if I'm going to take a point light here, and I'll make it like a lot brighter. Let's do like, I don't know, something like this, right? So here we can obviously see that we do actually get a lot of shadow cast in. But this is also very high-res shadow map. But you can see that here, for example, we do get a little issue where the shadow is not really connecting. So if I would go in here and add the contact shadow, it closes the gap. So it's just like, it's not a shadow that casts like a large amount of shadow. And actually here it's even introducing some artifacting. It would, yeah, interesting. So now it just got better. So like, this just basically closes the gaps. And it's kind of like really neat here, but now we can see that it's actually longer than our actual shadow. So if we just remove this, so it can also cause issues, right? So you don't want to make this so long as that it starts overriding the actual shadow map. So this is a feature that has to be tweaked very, very carefully. You just want a little bit like 0.02 here, for example, and that already helps with the contact information, which is why these are called contact shadows, because they're supposed to fill the gap between the filtered shadow, because the filtered shadow has like a little bit of like a bias and stuff like that. So it can sometimes create this effect where it feels that something is not grounded. So if I, for example, take this guy here, that is probably not supposed to be in the ground like this, but whatever. So if I take this and just move it over here. Are we? Holy shit, where did I move it to? Okay. Actually, we don't even need this guy. I just noticed we have our shield here. So like sometimes we can get this effect where we can see here clearly that the sign here, it is inside the ground, right? But we can see that there's like almost like a gap here in the shadow casting. And that is because these shadows, they have a certain resolution, so sometimes they cannot represent certain small details. And we do have similar issues most likely elsewhere. But for now, let's look at this. So if I'm going to take my directional light and I'm going to start adding these, this will start connecting. So that is what the feature initially was designed for. However, now that we have this technique here, you will see that as soon as I turn on the contact shadows, we'll actually start seeing something here. So I'm just going to do 0.04, and now look what happens. So now we suddenly got shadows here from these little stones. And they will react to the rotation of my light source. Oh, we got a shadow here. And again, like, this is not geometry. You can see how the shadow actually starts fading away when I go to the screen edge. So if you look here in the right side bottom of the screen, you can see how the shadow fades in and out because it is screen space. However, it does add a lot of perceived depth to the material. So again, if we just like do this, we can see like now it feels almost like this was being tessellated or something, which it is clearly not. And also if we look over here, we can see that now our shadow actually starts connecting. And one other cool thing is that here we have all this mesh scattering. And this mesh scattering doesn't cast shadows either because of the same reason that we don't get the contact information here. So with these screen space shadows in place, we can see how all this geometry suddenly casts a nice shadow. So obviously this looks a lot better, and it really helps to sell all these little details. There's a little bit of bugginess sometimes, so you can see like here, it's like they're not like always perfect, especially in combination with vegetation and overhangs and stuff like that. But for example, when you have like some really dense grass, using the contact shadows on grass, it just makes the grass feel so much more three-dimensional, because usually your shadow resolution is not good enough for grass from the directional light. And this technique is something that was heavily used in Ghost of Tsushima, for example, to get grass shadows. So if you play Ghost of Tsushima, have a look at it and do this thing where you like rotate the camera, and then you can see how on the screen edge, how the shadows of the grass are disappearing when the grass itself basically starts being out of the screen. So now a really interesting thing that I noticed is, because now since we have the virtual shadow map, things actually change a bit. And I was really surprised to see that, because again, I did not know. So if I turn off, let's go to a proper spot here where we have, so here we can see, here we have the texture with the shadows, and here we have like the mesh scatter. So we have both, right? So if I turn this back off, again, no shadows at all. So now look what happens when I turn on the virtual shadow map. So suddenly, with the virtual shadow map, we actually do get the same height map shadows as we got before without, if I do this, without the screen space nature. So this seems like the virtual shadow map, even though you can see that it does a little bit of a wonky thing, like now the shadows are disappearing, now they are appearing. So there is something with the pixel depth offset that does feed into the virtual shadow map. Again, I did not know that. So this is actually like a cool discovery in that sense, that we still get these sort of like things happening here. And I think that that it changes is probably based on how the pixel depth offset gets computed and some other stuff of how the shadow map traces against this. Like, to be honest, I'm not entirely sure. But again, if I switch this back, we can clearly see that we do get a lot more definition from the virtual shadow map. So now one thing that you noticed is like, okay, so cool, we have the virtual shadow map. Also, the virtual shadow map has a lot of resolution, which means we do get these really nice hard contact shadows here that then become soft, like it happens in reality, like nice soft shadows here. So, however, we don't really get any shadows from these small little like pebbles and all the mesh scatter here. Like even like looking at the twigs, like no more twig shadows. So what is going on here? Why did it work when we do set this, right? So, and the reason for that is the screen space contact shadows, they don't know about content specific settings because they run in screen space. So that means they get actually calculated based on the buffer targets. And the buffer targets is this stuff here. So this is basically like, if you want to understand physical based rendering, I'm not going to go into this. I mean, it's not necessarily purely physically based rendering per se, but it's just like deferred rendering versus forward rendering. These are the most common techniques used for rendering, and Unreal uses a deferred renderer. And if you really want to understand what is happening here, you would want to read up on how a deferred renderer works. And it works by basically creating these, what we call buffer targets. So like base color, specular, subsurface, normal, all these types. And the calculations that are done in screen space are done on these buffers. And other calculations too, but anywho. So one thing to know is that the contact shadows, they work on everything in the image. So like if I have an object, so let's say, I don't actually know if this is like, yeah, we can just select this. So if I go in here and I turn off cast shadow, we see that we still get this thing here from the screen space shadow. So let's go in here. And so here you can see how we still get the screen space shadow growing in. So the screen space shadows, they ignore the settings of the object itself because they have no information about that object. So what that tells us is that since all these little pebbles don't cast any shadow, they probably have their shadows turned off. So if we don't want to use the screen space contact shadows, but we want to fully rely on the virtual shadow map, and we do want all this stuff to cast shadows, we probably need to fix some settings here. So let's just go over here where we have a lot of this. So now how is this done? So if I click this, nothing really happens despite that we select the landscape. And this is different from selecting, like, let's say this bush here. Because here you can see this is all part of a instanced foliage actor. So what is this a part of, you might wonder? And this stuff is distributed using the landscape grass feature. So what we need to do is we actually need to look at the grass types and figure out how they're set up. So for that, you can see it goes away when it says building grass maps, and that is an indicator that all this stuff is scattered using the grass system. Which is fine, because the grass system is not necessarily only for grass. It is basically just scattering meshes across the terrain. So we need to go to the master, all very clean here. So here we have our grasses. And we can just start with the first one. So we can open this and we can see inside of this. So this UI is really annoying, sort of, because there's a lot of stuff here. So what we're gonna do is we basically search for shadow. Whoops. And now we just basically turn them all on here. So you can see these ones are probably bigger meshes. So we're just gonna turn them all on and hit save. And then we're gonna go into the next one, which is the cacti. We're gonna search for shadow. And again, like, I have no idea what's all in here, but we're just gonna turn all these on. And again, like, if all this stuff would be like nanite and whatever, we wouldn't even have to worry about like the screen space shadowing stuff and all that. And most likely we would not even turn some of these things off. We would just like roll with sort of the default settings. But I just kind of wanted to explain quickly how this has probably been made and how it's probably working. So I think it's important that like everyone also has options, right? So like there is no right or wrong here. There's just like really preference. But I think that if you work in a way how, for example, the Valley of the Ancient was done or stuff like that, you may not like do this, but if you want to work that way, you at least know it's a thing, so you can do it. And again, it is never really about what is right or wrong. It is just about what are the options, what is it that you want to do, what seems the most beneficial to what you're trying to do. And personally, I feel that that is always the way to go then, because, what is this? Okay. Because, you know, like no one is judging here. It doesn't really matter at all. So let's just go this way. And we're working so fast that the the grass map rebuild doesn't really follow quickly enough, but that's fine. We'll just set this all and then we let it think for a while and we should be good. And this should be the last one. And now we can see how all that stuff is actually casting proper shadows. So now we basically have the same as with the screen space shadows, and also we get like the shadow from the height map here. So all in all, this is pretty cool. I mean, there's still like stuff where this seems a bit flat and all that. Like this would probably be better if it would be a little bit more like, yeah, wobbly in general. But again, nothing much that we can do here. But now everything, all the twigs, all that kind of stuff, this just like works well here. So definitely an improvement. Nice. So now that we have looked at this, one thing that I also wanted to do was look at the bloom settings in our post-process volume. So I think I've mentioned it a few times already, but personally speaking, I'm a very big fan of like like one of the biggest problems with CG stuff in general, and that is not only like games, right? It's that things quite often look a little bit too clean or too pristine. And I don't remember who said it, but I just loved the saying. And the saying was basically, imperfection is the digital artist's perfection. And I love it because per default, everything that we build is more or less perfect, but that is not how the real world looks, which then makes things look like sterile or fake. So like our job, and not only like as 3D artists or like whatever type of artist you are, our job is to introduce very tiny layers of imperfection into our work so it actually does feel more believable. And since this is a lighting course, a lot of the things that we can do are obviously related to lighting and to cameras. And we've talked a little bit about it in some of the earlier sessions where I said like, hey, let's add some grain, let's do some very tasteful tweaking of chromatic aberration. And one of the things that is actually one of the most important things, I feel like, is the bloom. Because, so we, first of all, quickly, like, we only have limited ways of simulating stuff here, because we have to work a bit with the features that we just get from Unreal. And you can do a lot of like fake lens effects using particle systems. However, that is not really what's going to happen in this course, because this is almost like a course of its own on how to like emulate lens effects using particle systems and all that kind of stuff. It needs some very specific texture creation. It has some quite involved math, but it is absolutely doable to do these kind of things. But what we're going to use is we're going to use the features that we have at hand. And so if we're going to go into the bloom, this is basically what bloom simulates is sort of like what happens inside of a lens when really strong light hits the lens, and then there are interactions that happen between the different lens elements inside of a lens that can cause something to bloom or to leak, and it creates certain effects, right? And now what we have here is we just have our standard bloom settings, right? So we have the method, which is set to standard. We have an intensity, we have a threshold. This stuff does not matter until we change this up here. And so the threshold to -1, as far as I know, means that here, -1, all pixels affect bloom equally. So it is like Yeah, it is basically like, so if we want to limit the bloom to happen in only certain parts of the image, we can like exclude it from other parts that are not bright enough in that sense, right? So the first thing that we can do is to just illustrate this here. We can crank this, right? And this is like, this is Oblivion here. Elder Scrolls Oblivion, I mean. It's this like, maybe some of you remember like back in the day when before, like, because in the early days there was no bloom. And then suddenly like video games discovered the bloom feature. So every game just had like so much bloom and it looked awful. And this is sort of like a bad telenovela or something. But so the thing is, you kind of really want bloom when something is hit by like a very, very, very strong light. Like this does not look accurate either, like back here. So let's reset this. And if I just like increase this a bit, you can see how this just starts tiny little bit like glowing. And also like back in the day when there was no like volumetric simulations, people also used bloom to create this more dense atmosphere. But again, it creates this really dreamy look. And one thing that we can do is like when we have, let's say we want this, right? But like we want to control this because like right now the threshold is set to this, so it's affecting everything equally. So let's first start with a 0. And now we can see that this is basically doing kind of what we want, because now what we're getting is where the light hits at grazing angles are really hot. Like look at this. So it is basically still hitting a lot of the stuff, but it's kind of like where the sun hits the most, it really blooms. Because without this, it kind of like blooms everywhere. And if we set this, we can see like, now it blooms here, where it's like hitting really hard, right? So we can see how this is actually changing things up in a cool way up here. So this may look a lot more filmic in that sense because we're having this effect now. And then we can obviously tweak this even further, right? So we can see now we sort of like compare this to 0. We've removed a lot of the parts, and then it depends on how strong the sunlight would hit, we would actually still get bloom back in. So here we do get a lot of bloom. You can see that next to the car. So if I would do this, there's even more bloom. So we can sort of say how strong does something need to be hit by light to bloom, and then when it blooms, we're gonna kick in at like super high intensity. Because before that, we obviously had this. So it kind of like looks the same as we would like increase this value, but this is just really how strong the parts bloom, and this is kind of like where do the parts that bloom end up being, okay? So this is really important to tweak this properly, and doing like a quite high intensity, but at the same time keeping the threshold in check can actually be really beneficial to create some good looking stuff. So this can be really nice. However, now let's get to the important part. Oh, sorry, also one thing before we go to the important part. Down here, you can tweak the bloom as well. And I'm not sure if all this, okay, it seems to work, because in Unreal 4, some of these were like completely broken. So, for example, I'm not sure if this actually does work. Let's see. That's one. Okay, here we can see now this is purple. So this is fantastic, because in Unreal 4, this was completely broken, and it was really annoying because like using this stuff here, this is like so much fun, because you can really like change a lot of the behavior. Actually, I'm wrong. Sorry, I might need to correct myself because I'm not entirely sure if this one was broken in Unreal 4, but what was broken was the lens flares and these ones here. So these ones did not really work in Unreal 4 because you can use these to like move the elements and all that. So we're gonna look at that in a bit. I'm sorry for mixing these up. I think the normal bloom used to work. So no, but what I wanted to talk about is lenses have very specific behavior. And what that means is that, like, for example, the way that they flare, so bloom is not a word that exists necessarily in photography. It's more flaring. That is what it's called. And if we look at some of these elements here. So obviously we all have the beloved J.J. Abrams stuff that everybody loves to hate. And all these kind of things. But so basically what usually happens is this, right? So we have a very bright light and then it scatters throughout the lens and it usually creates, this one is called like a star flare or a star burst. And then the lens flare is actually these little elements. And the way that they come into existence is that when you have like a lens, so let's say like this is the lens, right? Beautiful lens here. So inside the lens are obviously like a tons of lenses and they all have like different like things, how they're like built and they're like shaped differently and yada yada. And here we have the sensor and the light kind of like goes through this and then stuff happens, right? So when you see stuff like this here, like these traditional flares, or like this is, for example, very beautiful here. This is what I consider to be a beautiful lens flare. So if I would make lens flares, I would want to have something like this. And these shapes that we see is light refraction going through these different lenses. And then when you like move the camera, they also parallax in different ways. And this, for example, is something that I consider to be not a very beautiful lens flare. It just depends on also the aperture and stuff like that. But I really like stuff like this. This looks rather fake to me. That's probably made in Photoshop. But there are some really, really beautiful lens flare effects. And you can see this one is probably a mobile phone lens. So these effects with these dots and things, they often happen with mobile phones because their lenses are built in a very, very specific way. And here again, we have a beautiful starburst. So when an image, like when something blooms, usually things like this happen with the lens. It's not that it just looks like this here, right? So like if I would go in and let's say 20. So here you can see this is just like an equal effect. So it just basically blurs this and like it just glows around, right? And again, this is not necessarily what would happen. What would happen is something a lot more like this here. And to simulate this, there is another version of bloom inside of Unreal, which is called the convolution bloom. And now we could see that a little bit of something happened to the brightness here. And one thing that is really important to know with the convolution bloom is that the convolution bloom per default, it has a bunch of settings down here. So like not all of the settings work for the convolution. So you can see like the intensity, it does. But for example, the threshold does not. Then we have this thing here, which I actually haven't used. Okay, this would be an interesting thing to try. Okay, yeah, no. Let's not do that. So the convolution bloom has the settings down here. So what does the convolution bloom do? The convolution bloom uses a kernel texture and scatters it around the screen, and then it uses these parts where it should bloom and it modulates them by the texture. And per default, even though this says none, there is actually a texture that is being used. And it's this one here. And if we open this texture, this is what it looks like. So we can see this is actually a really nice starburst bloom-like effect. And the most important thing is this texture is an HDR texture. So you can see that when I expose it differently, there's so much more information that is visible here. So one thing that I really dislike is I really dislike this green and red color. It's like quite often these become visible when people use these textures in Unreal, and you can instantly tell it's the default texture because it has these colors and stuff like that. But like, there's nothing wrong with this. Like, these textures, to make them, it is rather difficult because you need the high dynamic range, right? It needs to be an HDR image that has all this. And so how these are usually created is you take a camera and then you point a flashlight straight at the center of the camera lens in a pitch black room. And then you take pictures with different exposures and then you merge them into an HDR image. And that is how this is usually created. You can also render this with like some stuff, but it is quite nice when you have a good camera and a good lens to shoot this based on your lens. Anyways, now that we have this specified, what we need to do is these settings down here, they are not tweaked for physical values. So we don't necessarily get what we want up here, but you can see that there is something sort of affecting things already. So that was mostly the intensity here. So how do we tweak this? Let's try something nice here. I'm gonna see if I can just place a light in here where we have our metals. And now I'm gonna just make this like way too bright. And now we can see here is the bloom hitting. So here you can see how this is kind of like having the star shape kind of thing. And if I switch back here, it looks like this. And this is not very photorealistic. However, this is a lot more photorealistic. So this is kind of like a good way to tweak it. It also kind of seems like they have improved the default settings a bit more. So it kind of seems to work with these physical values quite well. Because I remember in Unreal 4, it did not really work out the same way. So let's see. Yeah, this is just shrinking it. I think I used to tweak this value here. But it actually seems kind of like okay for now. So maybe we don't really need to touch it much. But one thing that I want to try, since I told you that I don't really like these colors a lot, I thought, hey, is there any way to make this like feel better? And what I did was I kind of did this here. So per default, I actually like added in more variation here. So you can see that like I just wanted this to be a bit more complex, kind of like this. We may actually tweak this a little bit more. To something like this, I think. So I was just trying to see, hey, how does this feel if I make it more complex? And then I changed also the colors a little bit. So when I expose it like up here, you can see that it is not as green as before. And I just wanted to try that and see how it feels. So we can just save as here. And let me see where to put this. We need to do save copy. And I think it should, EXR should be fine, I think. All right. Didn't seem like it has saved it. 1 second. Pictures. Okay, now it has done it. Okay, cool. So we have this. We're gonna open up our content browser, go into my lighting folder. I'm just gonna add my bloom kernel texture. So now I have it here, so we can see it. And let's see what happens when we apply this. And this is very interesting. So there could be a bunch of reasons for this. So the first thing is I'm gonna open this one here. And then I open mine. And now what we need to do is we need to make sure that we have the same settings here. So probably go with no bitmaps here. Texture, all good. Is there anything else? I think this should actually be it, but let's see. So I've never done this before, so, you know, oh, this is actually quite interesting. Kind of curious why this is happening. It could potentially be the changes that I did to the color. So I'm just gonna turn off the color changes. And save it again. because it shouldn't really cause any major problems. Yeah, so it probably was the color changes that I did. And the cool thing is, like, this stuff, it can actually look like pretty cool when you have, for example, a little light bulbs and stuff like that. So I'm just going for my good friend, the editor sphere. And I'm just gonna scale this down. Oops. Like 0.1. So we have this here. Obviously still a bit too big, but that's fine. And I'm gonna do this really quick and dirty. I'm just gonna take my sky material here, and I'm just gonna crank the brightness. There you go. So we'll basically turn this into a little glowing ball. And here you can already see how we have these, like, because there's varying brightness, obviously, we have these different kind of glow bursts happening. So let's do 0.05, 0.01, 0.025. Let's do this. All right. So, and now I'm just going to crank the brightness more and more. And now we can see how we're starting to get this, like, a lot more interesting blur shape here. So you can see we're having something like this. And this does look a lot more natural than this, right? So we can use this. We can also just like go back to the old kernel, which is like this. So, you know, like I was just really playing around with this here, trying to do something. And this is definitely what I recommend to be used for the bloom and all these kind of things. So we will get a lot more natural behavior, generally speaking, when we have bright stuff, which could also like become important for this stuff here when we're like inside, and we'll have like a different exposure, which, okay, still not bright enough, but you know, we'll get there. It'll all come together nicely, but overall, this is just what I feel like should be said in general. So this took quite a bit of time to do all this, but I hope it was interesting and you learned a bunch of cool things to try. Regarding the bloom texture, so what I did here was I used the channel mixer to change the color, and that was the thing that made it go all bonkers. So now you know, don't do that. Don't use the channel mixer. I think that hue and saturation is usually fine, but it can introduce some artifacting. So this one here is just a rotated version set to lighten. So that is no problem. So basically this change did not really make any difference. So you know that too. It's not really a problem. But if you want to do stuff like that, don't use the channel mixer. And so yeah, we've now looked at all these things. And in the next session, we will continue to go through the elements that are not necessarily the natural lighting. So we're gonna just make sure that all these values work here, because ultimately what we're gonna do is we work towards a setup where we can do different times of day and different light settings, and all the things, they will just work in tandem. So right now we've done like the exterior setup, we looked at a bunch of other things, but we need to get the local stuff done, like the emissive values, the lighting, all these kind of things for insides. And then we can do a bunch of variations with different exposures, and we'll always get working lighting that looks cinematic and is just very, well, pleasing to look at. So yeah, thanks for watching, and see you in the next session.